Okay, we're going to move on to one of the tougher topics in this chapter. It's called reflecting a point over an oblique line. An oblique line is basically a line that's not a horizontal line and it's not a vertical line. So it's basically a slanted line. Okay, and what we're going to do is we're going to reflect a point over oblique lines. And so there's easier ones and there's harder ones. Let's start with easier ones. Okay, so this first problem here is we're going to take a point, 2, 4. So let's graph that point, be right there. And we're going to reflect it over the line y equals x, negative x. And so hopefully you recognize that that's going to be a 45-degree line that has a negative slope that goes like this. Okay? And that's something you should have learned from last year. It has a slope of -1. So it goes, the slope goes down 1, over 1, down 1, over 1. And if I want to reflect the point over that given line, I know that the point is going to be over on the opposite side of the oblique line, and I know it's going to reflect in a way that this blue line here is going to be perpendicular to the line of reflection, to the line that it's reflected over. And I know that this distance here is going to be the same as this distance right there. So if I look at this thing and I can kind of take a look at it, I'm guesstimating, I can see that it sort of falls right there, and I'm going to check it because I know that this slope, this blue line slope, has to have a slope of +1 since it's perpendicular. So if it's +1, I'm going to check it. Go down 1, over to the left 1, down 1, left 1, down 1, left 1. Sure enough, it's going to fall right on one of the points that's obviously on the red line. So I look at this thing and I see that this intersection point, and this is my original point. Well, I can find this point over here simply by counting using the slope. So I'm going to go down 3 and to the left 3 to get to this intersection point. I'm going to do the exact same thing. I'm going to go down 3 and then to the left 3 to get to my point of reflection right there. So I know my point of reflection is going to fall at -4, -2. And that would be my answer. Okay. This next problem is the same thing, same type of thing. It works out really nicely. So let's do some graphing here. I have the line y equals -2x minus 3. So I know it goes through the y-intercept at -3, because that's my y-intercept right there. And I know it has a slope of -2, so it's going to go down 2 over 1, down 2 over 1, down 2 over 1, and so on and so forth. I'm just going to go ahead and go the other direction up here and graph this line. Hopefully you remembered how to graph lines from last year. Okay, you should be strong at that from your Algebra 1 background. Now let's take a look at the point that I have here. And the point is 6, -5. So 6, 1, 2, 3, 4, 5 in the negative direction. So it's right there. And I know that, again, it's got to be like perpendicular going across. And I know it looks like it might go through that point there. I need to verify that. I need to make sure that it's going through that exact point. So the way I'm going to do that is I'm going to take a look at the slope of this guy. So this slope over here has a slope of -2. So that means that if this slope is -2 right here, that the slope of the red line has an remember, it's got to be perpendicular. So the slope of the perpendicular is going to be positive 1/2. So let's try this. If I go down 1 and to the left 2, down 1, left 2, it looks like I hit this point, which is on the green line. So it hits it perfectly. So that's nice. I know that the intersection point must be 2, comma, -7. And so if I'm trying to figure out where the reflection point is going to be, I'm now going to take a look at going from the original point to the intersection point. So it's going to be down 2, left 4, excuse me, and then down 2, left 4, and there's my reflection point. It's going to be at -2, comma, -9. So there's a couple of things here. That only works if it works out just perfectly, where it hits it on the graph. Sometimes, in fact, a lot of times, it's not going to hit it, and that's where these problems become a little bit harder. Or if we're not given a really nice graph like this. So let's flip over to the back side and let's try a couple where it doesn't hit perfectly, or it's not too easy to see on a graph. Okay. Okay, so now I'm on the back side. These problems become a lot tougher when I don't provide a graph. So let's draw a quick Cartesian coordinate system here. Here's my x and y axis. And I have a point, -1, +2, so something like that. And I have a line to graph here, so it's going to go through -6, 3, 4, 5, 6. There's my y-intercept, and it's going to go up to the right 3, 1, 2, 3. And so the line is going to look something like this. And so I know from what we were talking about on the front side, I know that there's going to be a line that goes something like this. It doesn't necessarily go through that point right there, but it's going to end up, if I reflect it, somewhere about there. Okay, I don't know exactly where. And if you remember on the front side, what I need to do is I need to find this intersection point right there. I need to find that point. I don't know exactly where it is. I could try counting, but I don't have a nice graph paper. And so let's find that intersection point simply by doing this. I'm going to find the equation of the red line, and I already know the equation of the blue line. It's that one right there. So the equation of the red line is going to be, well, the slope's going to be opposite reciprocal, right? So the slope of the perpendicular line is going to be -3/2, right? Because this is +2/3. And I know it already goes through this point right here. That's this point right here. So hey, I have a point and I have a slope. So now I can go ahead and put this red equation into point slope form. So the equation is going to look like this. It's going to be y minus 2 equals -3/2 times the quantity x minus -1, or plus +1. So that's the equation of the red line. I know the equation of the blue line already. That's just going to be y equals 2/3 x minus 6. And now I can go ahead and I can solve for the intersection point simply by solving the system of equations. So if I take this equation right here and plug it in for y right there, I'm going to get 2/3 x minus 6 minus 2 equals -3/2 x plus 1. And I can solve this thing. Let's go ahead and combine these two. So it's going to be 2/3 x minus 8 equals -3/2 x plus 1. Now the yucky thing about this equation is it's got all these fractions in it. So if I want to get rid of the fractions, I can multiply the entire equation. Now we did this a little bit earlier. Multiply the entire equations by 6. And so now what I'm going to end up with, if I do that, is I'm going to end up with 4x minus 48 equals -9 times the quantity x plus 1. And then I can solve that thing pretty easily for x. X should end up being equal to 3. And the y value, if I plug it back in to one of the equations, is going to be equal to -4. So this point right here, let's change it, the color to green, this point right here is going to be 3, -4. And so, if I want to find my reflected point, I'm just going to do the same thing I was doing on the front side. I'm going to go down some amount, and I'm going to go to the right some amount. And then I'm going to go down the same amount, and go to the right the same exact amount. If I do that, I think it's down 6 and to the right 4, I'm going to get 7, -10 as my answer there. Okay, so here's a practice problem for you. I'd love for you to try it on your own. I'm going to give you the answer that you should get. The answer you should end up with here is -2, +12. So go ahead and if you have some time, or if you are looking for some practice, do this problem here. It's not too bad, but do a quick sketch and then do the reflections, find the equations, solve the system of equations, and then use slope to find your reflected point. And the reflected point should end up being -2, +12. All right, that's it. Sorry I had some problems there with my pen, but hopefully this video, by the time I edit it all, it will make some sense. All right, take care.